Looks like we're about to get some rain. Anyway, look at this here. Now this is a little bit, obviously it's not a direct equivalence to the natural world, but it's not that far off. It's more of a matter of scale than anything. You can probably tell a little bit that this is coarse stuff, you know, depending on who you ask. It's a fine gravel or coarse sand. But anyway, you see we had a bunch of rain this weekend, and you look at the comps here and you can see these deep cuts because there is a slope here. It's less or about 30 degrees, I think, if I remember correctly. But anyway, you look and you get the heavy rains and notice like the whole thing just doesn't wash down. What happens is you get these like little cuts, these incisions, these V-shaped valleys, right? And they start cutting down, and then where the slope changes drastically, you get, it dumps the heavy stuff it can no longer carry, and you get an alluvial fan deposit at the base. And that's what we have. Now you look at the pattern here, and you can tell the streams are trying their best to meander, but what happens is it just down cuts. You get pretty straight streams. This is basically a complex of braided streams is what it is, even on this slope, even though it is down cutting. This has to do with the nature of material. If you go into the stuff that has a lot more topsoil on it and stuff, it behaves more like you'd expect it to behave. But here, so you get the cutting down and then you get the drop here, and you can see there are even braided channels on top of the alluvial fans, and there are several alluvial fans. If you look in the back there, you've got one up front here, you've got another, and so you have at least two, possibly three. It's hard for me to tell here. But then you look over here, and this is one that starts out like the other one, but then it gets into topsoil and seeds and vegetation. You can see it drops most of its load a lot sooner, that coarse stuff, because it can't carry it as far as it can in the other side. Now it has some here at the base, but you can tell it's branched out. You've got, instead of overlapping fans in one area like you have here, what you have is you have what? 1, 2, 3 areas, and those two touch more than they overlap. So that happens too. So you get these diverse environments, and this is really, you go up and down here, and you can see this after a rain. And this is pretty much what happens on a larger scale in the natural world. But even with these alluvial fans, you look at them, and you know, from the side, you can tell they're not dipping very much. Like I said, the slope here is maybe 30 degrees. Okay, so that means that these are a lot less than that, 5 to 10. And the further you go, if the rain had a lot more power to it and the water had a lot more load capacity, these alluvial fans could be less than 5 degrees initial depth, and they're terrestrial deposits. So you don't get a lot of initial dip necessarily on a terrestrial deposit, but you do get some. You know, it's not like a beach sand or something like that where you get a lot higher angles. Anyway, I think that's it.